So we had left off on decision making, basically talking about different ways to actually use selection measures. One of the other ways we can look at it is multiple cutoff approach. So we're building off of just using multiple regression. So if we're using multiple regression, we're using a series of selecting tools, each one of them a continuous quantitative value. So it might be a cognitive ability test, it might be personality scores, it might be performance on job-specific tests. It may also be ratings on how well they did in their interview or ratings of their resumes. And we use all that at the exact same time to put into a regression equation to predict how well that person would do as far as performance based on previous data of how well those particular selectors predicted performance in the organization. So one of the problems with that method, and we kind of discussed this as one, is that it does require a fair amount of statistical knowledge to be able to use multiple regression without making some mistakes. The other thing is that it takes all of those predictors into account at one single time, and that also means that you need all of those predictors. So a lot of organizations have moved to a more systematic approach, and one of those is multiple cutoff approach. The assumptions here is that there's minimal proficiency required on one or more variables, and that there's basically a curvilinear relationship. And what I mean by curvilinear relationship here is that if it's a curvilinear relationship, that means that as you increase on an outcome or a predictor, so let's say that we're looking at the relationship between cognitive ability and performance. The belief here is that to a certain point, there's a linear relationship. So as you increase in cognitive ability, so does your performance. But also there's a leveling off, and that's the curvilinear part. That at a certain point, more intelligence does not necessarily mean better performance. So there might also be a minimum proficiency of hand-eye coordination. And you need at least a minimum level to do well in the job. But once you've attained that level, gaining more and more hand-eye coordination is not necessarily going to make you any better at that job. So an assumption here is that, like I said, there's two effects, that on each one of your predictors, there is a minimal proficiency required, and that if you don't have that minimal proficiency, that basically you would not be able to do the job. And now an advantage to multiple cutoff approaches, again, remember that multiple regression actually would allow your very high scores in other measures to make up for a deficiency in a poor score. So using multiple regression, you could get someone that is predicted to do very well at their job because they're very high on personality, cognitive ability, interviewing. However, they actually don't have the base level skill to do the job. So that's another advantage of the multiple cutoff approach, is that you actually set off these cutoffs through a process of selectors. With, again, the assumption there's also this curvilinear relationship, that at a certain point you shouldn't be doing regressions anymore because it isn't linear, that you need a certain amount of skill, and if you have less than that skill, you're going to perform poorly, and if you have more and more of that skill beyond the minimum, it may have a slight relationship with performance, but it is not a strong correlational linear relationship. So the other advantage to multiple cutoff approach is you don't need all the selectors at once. So you can actually stagger your selection tools to where the cheapest and easiest to administer can be your first with, again, a cutoff. And anyone that doesn't make that cutoff doesn't get any of the additional predictors. So it can also save money. Now, setting the cutoff is one of the major challenges to the multiple cutoff approach. So how do you set a cutoff that is basically empirically rigorous, so that you know that this is a meaningful cutoff? So there's a lot of different cutoff considerations. So are you only going to use a single cutoff? So is there one yes or no, or is there a lot of universities, for instance, will have a cutoff based on who they let into college based on their ACT or the SAT, but usually there's not a single cutoff, there's a couple of cutoffs. There might be a cutoff before, so you have to have this score or higher to be offered any kind of financial assistance or grants. At this cutoff, you're allowed into the university, but there might also be even a lower cutoff that you're allowed, but under a special kind of probationary status. And some organizations may want to think about this as well. They may want to have a cutoff that says basically, if you get above this score, we're immediately going to be looking at you. Above this cutoff score, you're under consideration. But at this lower cutoff score, if we have no other applicants, we might try you on a provisional basis. Another method for setting the cutoff considerations is Enghoff method, and this is basically just a way to take advantage of multiple raters. So the Enghoff method basically suggests that you get a group of subject matter experts to look at each predictor and then determine what, and they basically then rate what they think would be the minimum cutoff for proficiency. You then add all those up and average them, and that's where you get your cutoff score. So instead of one person making a decision on the cutoff scores, you have a group of experts, and you sum and then divide each one of their ratings to get a mean, and you use those means for the cutoffs. You can also use expectancy charts. So expectancy charts are basically decision-making tools, and that's what the numbered chart underneath is for expectancy charts. So you basically look at the number of openings per position. So how many openings do you have? The number of applicants, and then the ratio of successful applicants given to the historical preference of the incumbents, and then you look at the typical hiring rate. So having these four pieces of information on an expectancy chart, and we'll look at an expectancy chart used in basically determining the successfulness or usefulness of selection batteries in a few slides later. But it basically will give you a cutoff score. So there are expectancy charts made to generate cutoff scores, and what you do, again, is you look at all four of these factors, not just the ratio of successful applicants given historical preference. So that's what we've been talking about before. So if you use a single cutoff based on kind of a gut feeling, previous data has found that if we let in someone with a cognitive ability score of 110 or higher, they're very likely to perform well, so we're going to choose that as our cutoff. Enghoff method would be, again, just looking at number 3. We have a whole group of experts that look at the effectiveness of intelligence tests on performance, and their mean suggested that our cutoff score be 108.5. An expectancy chart takes into account other factors. It says, well, we know what the cutoff would be to predict or highly predict that someone's going to do well in the job. But that doesn't happen in a vacuum. We also have to know how many openings are you hiring for, how many applicants you have. So again, you can set a really high cutoff score, but if you have 10 openings and only 2 applicants, it really doesn't matter what your cutoff score is. You're just making a decision, are we going to hire anyone or not? And also the typical hiring rate. So having an idea of what is the average the company actually can bring people in at a time. So is it okay if you don't have a hiring this time because you'll be hiring next week or the week after? Or is the hiring rate much slower? In other words, if these positions aren't filled, they may remain unfilled for a year or more. And all of those can be factors that would need to be included in the decision on setting a cutoff. So essentially just guidelines on using the multiple cutoff approach. So basically when you're using cutoffs, you need to decide the cutoff score sensibly, usually data-driven, and usually based on the relationship between whatever predictor you're setting a cutoff score in and performance. Recognize that there may not be a single best cutoff score and that you're actually looking at a series of cutoff scores usually in the process. All cutoff scores and predictors should, of course, be based on a job analysis so that you can clearly tie this is a predictor that is related to job performance and is shown by both the job analysis and hopefully validity data showing that predictor and actual performance. You want to consider the validity and job relatedness of all assessments, and what I mean by there is that, again, remember that whenever we set a cutoff score, we're putting a finite single number on someone's score based on a correlation. And the more valid that predictor is with the outcome of performance, the more confident we can be that that cutoff score is doing what we think it's doing. The less valid, and that doesn't mean not valid, that just means that there's a smaller correlation coefficient, the more error there is and the more that cutoff score is going to be kind of fuzzy. And again, the job relatedness, that goes back to the job analysis. Generally speaking, you want to relate your minimum cutoffs with performance. So when you're looking at a cutoff score, and where that cutoff score comes from, again, remember, can come from 3 sources. It can be simply data-driven, it can be generated by a group of subject matter experts, or it may also vary depending on the business necessities of the organization. But you're always wanting to think of, we're wanting to use this cutoff score usually not necessarily to exclude large amounts of people, but to try to set up a minimum cutoff for performance. And again, the more that cutoff is related to performance, the better. If you're using the Enghoff method, you want to make sure you use an adequate number of judges. Generally speaking, the larger the better. A good rule of thumb is 5 to 10. You want to consider statistical and legal issues. So is the cutoff method, so for example, when you're using multiple cutoff, the legal issues are that now you're needing to check for adverse impact at every level of your cutoff system, not just the final decision. And again, you are still hopefully making these decisions based on some data, basically, the validity data, the relationship between the predictor and the outcome. So again, knowing that the statistics you're using are correct, that you're not violating assumptions are important. And you also want to make sure that you're setting those cutoffs high enough. So that's kind of a two-edged sword. You want to make sure you're not setting them too low or too high. So setting them high enough is making sure that you're not letting a lot of people in that would not be able to do the job. So multiple hurdle approach is includes multiple regression and multiple cutoff. It has the perspective of time to multiple regression. And what we're looking at here is that instead of every single predictor having its own cutoff score through a systematic process where you take a predictor, and if you make the cutoff, you get the next predictor. And if you make that cutoff, the next predictor. Multiple hurdle approach generally means that we're going to set up a system where there is a series of selection batteries. So each time that you go through a process of getting the job, you're basically taking a multiple regression, so multiple predictors that determine whether or not you move on in the process. However, as you move on to the process, then you hit another set of predictors with a cutoff. So this adds the perspective of time from the multiple cutoff approach to the multiple regression approach. It's appropriate when training is long, complex, and expensive. So usually what we're going to find with this is that a lot of times it will extend beyond the selection process, and that's what the term there, temporarily or permanently hired, means. So when Kristen Pankey was talking to us this week, so she was talking about her career in I/O. She kind of talked about the fact that a lot of the jobs where she was at, which was on the West Coast in Seattle, you usually don't get hired full-time initially. So you go through a selection process, you pass a multiple regression, you pass a cutoff, you get hired, but they don't hire you as permanent hire. You've made the first cutoff. You're now in a temporary contracted position, and that might be 3 or 6 months. Then during that time, they're going to measure performance, your job reviews, and other outcomes in another multiple regression. And if you pass that cutoff, then you may become permanently hired. So a lot of times, this is appropriate when the training is long and complex and expensive. So basically, we want to set up a selection method to find out who is likely to succeed in the training process, but we also want to check to make sure the training process is resulting in someone that can do the job. So examples include air traffic controllers, surgeons, tenure track professionals. So when I was hired as a faculty member, I was initially hired under a yearly contract that I then had to show in a certain period of time, usually 4 to 6 years, that I have done everything necessary to show that I'm competent at my job, and that when I pass that hurdle, that's when I actually become tenured, which is the academic version of permanently hired. So basically, I was, though an assistant professor and on the tenure track, I was considered effectively temporarily hired. So this is an example of the multiple hurdle approach. And that basically just reflects that some placement decisions cannot tolerate such weaknesses in validity. And what I mean by that is tolerate weaknesses in validity is we've already talked about that no matter how good your selection battery is, unless you have 100% prediction, in other words, an R of 0.10, 100% variance explained, there's always going to be some error. So when we create a selection test for a job that basically doesn't allow or have tolerance for error, in other words, there's really horrible consequences for poor job performance, usually that selection battery is going to be just a part of a multiple hurdle system. So pilots, surgeons, judges, you hire someone for the training, but then you also evaluate them after the training. They may then also apprentice, and again you evaluate them, and at any level they may actually kind of wash out and not end up with the job. And this is an example again of using kind of this multiple hurdle approach. So decision theory addresses weaknesses, so it basically recognizes predictions, accounts for the importance of outcomes and consequences, and looks at a lot of these factors. So basically, when we're talking about organizational decision making, multiple hurdle approach, and in these kind of higher risk jobs, recognizes that predictions always are going to have error in them. So we are going to sometimes predict that someone performs that doesn't. We're also going to sometimes predict that someone wouldn't perform that would have. So just looking at validity, all we have is success and failure rates, but we need to also then balance them beyond the statistical prediction into decision theory. So what is the importance or the outcomes and consequences? So if someone actually fails at the job, what's the cost? The lower the cost, the more likely we can accept some error in our prediction. The higher the cost, the more we have to come up with multiple hurdles or multiple ways to predict success in that job to make sure that there is not these high cost consequences of failure. And these consequences can be individuals, so basically the consequences for the individual career, the individual performance. It can be also organizational survival. So example right now, Chipotle fast food has gone through 2 big experiences of E. coli or food poisoning outbreaks. There is no question that that company is now having some serious questions about the organizational survival. So what are people still going to be willing to eat at our restaurants when we have been in the news twice in less than a year for major outbreaks in health safety? And that is an example of the consequences of some decisions that were made at some level in the organization. So when we talk about decision theory, we're moving beyond just statistical prediction and starting to kind of bring real-world utility about looking at the payoffs, the costs and benefits of how we're making these decisions. And that brings us to the idea, and decision theory primarily is focused on the usefulness of the selection process in the broader aspects. So this is kind of bringing us back out of statistics to what we talked about at the very start of the class, kind of that open systems approach. So when we talk about utility in selection and utility in decision making, we're really talking about trying to quantify how useful and cost-effective a selection battery is, or any decision making in an organization. So elements of the selection process that allow us to assess utility are the accuracy, so percentage of hiring decisions that are correct, the validity, so maximizing hits while minimizing misses, the base rate, the percentage of current employees who are successful on the job, and the selection ratio, the number of job openings divided by a number of applicants. So this is bringing kind of judgment and decision-making research from another field of psychology into helping us as IO professionals try to sell the usefulness of the decisions that we're bringing to organizations. And in order to do a utility analysis, what we're needing to know is basically what is the percentage of hiring decisions that are correct. So if you hire 100 people, how many of those people actually end up performing at the level you expect? That's our decision accuracy. We want to know the validity, so basically the coefficients of our prediction batteries, whether it is a multiple cutoff approach, whether it's a multiple regression, whether it's a multiple hurdle. We still want to know at the end, once you put all of this together, what is the amount of variance being explained in our predictors of actual performance. And again, the higher that validity, the higher that coefficient, that means we're going to be getting more hits and minimizing our misses. We also need to know the base rate before any change or before any intervention. So the percentage of current employees who are successful on the job. So usually base rate is going to be what happened before we brought in a new selection battery. What was your success rate at hiring before we changed how things are going? Because when we're using utility, we're almost always trying to sell a new technique. We're trying to illustrate, here's what your organization was doing. Here's the base rate. Here's the validity of this new selection tool. Now let's take a look at, based on that base rate, how much more accuracy are we getting with this validity? And in all things, again, we need to know the selection ratio. So if you have 10 openings and less than 10 people, all of this is kind of moot academic arguing. Selection batteries and any decision-making tools that we use work best when a decision is actually being made. So if an organization basically only has one person that can be promoted, then there's really no reason to talk about utility or the use of any of these techniques. These techniques are for when a decision is actually before them. There's 20 people that are wanting one promotion, and we want to come up with a better way to non-biasly help make that prediction decision. We have 10 openings and 100 people applying. Out of those 100, which 10 would be the best fit for the job? So again, that's selection ratio. So decision accuracy is basically just a percentage of hiring decisions that are correct. So again, looking at a precision, so we've got our standard correlation there on the right. We've got our 4 quadrants basically at the bottom. Q2 is correct rejection. So that is, and again, the 2 lines that are drawn there, the line that's going horizontal is basically successful performance. The line that's going vertical up and down is the cutoff we have determined on our group of selection batteries, however we're doing it. So Q2 is our correct rejections, Q4 is our misses, and again, a lot of times we are inferring this data because we won't have it, because we didn't hire those people, so we don't know if they would have performed or not. But based on the quadrants of Q1 and Q3, the data we usually have, we can then extrapolate what the rest of this graph will look like, assuming a linear relationship. Now, sometimes if we are lucky, we'll get in an organization that will actually let us use a new selection technique on the entirety of the employees that are already hired, including ones they know aren't working out very well, so we might actually have all of this data. So if we want to know decision accuracy, we just need to divide the number of people that are in Q1 by the number of people in Q1 by Q3. So that's the data we have, decision accuracy. So we used a selection technique. We had 100 people applied. We hired 50 of them. Of those 50, 45 worked out and 5 failed. So that would be 45 divided by 50. So again, the total number of people hired at the bottom divided by at the top the people that actually are working out. If we actually wanted true decision accuracy, we would need all that information. So overall decision accuracy is both our hits and our correct rejection. So Q1 and Q2, the people that basically we predicted correctly, the people we predicted that performed well that did perform well, and the people we predicted that would do poorly that did perform poorly, divided again by the total number of people we're screening. So the goal of a selection battery is always to maximize hits and correct rejections and to minimize misses and false alarms. And again, just by the very nature of how this works, the more valid, the more variance we're explaining, the more narrow that band's going to be. The more hits we're going to get, the more correct rejections we're going to get. We're maximizing those, and we're going to be minimizing those misses and false alarms. So decision theory models, looking at utility, we do need to look at the erroneous acceptances are costly, so we have to ask what is the cost of a bad decision. And a lot of times this helps us decide what the cutoff is. So if the costs for a bad decision are fairly low, we can set a reasonable cutoff that's getting us a majority of employees that can do the job well, but occasionally is going to miss. In other words, we can set our kind of boundaries of how many people we want to let in based on how many are going to succeed. But as the acceptances become more costly, so if failure on the job means lawsuits, injury to existing employees, risk of life, risk of possible death, so basically think of very high stakes jobs like, again, maybe a surgeon, that means we're going to have to move our cutoffs to where the chances of us making a miss of hiring someone that we shouldn't have hired needs to be smaller and smaller. So erroneous rejections are hard to quantify because of out-of-pocket expenses. So that means even outside of these big ones like risk of life and surgeons, also just the administrative expenses and legal defenses of bad hires. A bad hire is going to be a reduced performance coming from that individual. There's going to have to be the legal issues if that person is terminated, not to mention the administrative expenses of an additional hire. So when we're estimating utility, we're generally needing 3 pieces of information. We need the validity of the selection battery, the correlation coefficient. We need the base rate information of what the organization's success in hiring was prior to our new selection battery. And finally, the selection ratio, how many people are actually applying compared to how many openings there are. And there's a lot of tables that you can actually find. There's books that have been written on this. The Taylor-Russell tables are often used in estimating utility, and that's what we're going to look at next. So here's an example of a Taylor-Russell table. So again, we've got the base rate at the far left. We've got the validity coefficient in the next column. And then finally, we have the selection ratio. So what percentage of people are we actually being able to bring in? So the base rate was the success rate prior before a new prediction battery is brought in. So one of the things that you can notice immediately is the lower the base rate, the more successful probably a prediction battery is going to be. The next thing is that the more valid the prediction battery is, the more utility it's going to bring, so the more success. And finally, both of these factors become kind of pointless if you don't have a very high selection ratio. So just quickly looking at the base rate of 30%, let's go to the selection ratio of 0.8. So that means for every 100 people that apply, 80 get hired. So notice that if you have a 30% success rate, if you bring in a new measure that has no validity whatsoever, basically the base rate is going to be remained unchanged, 0.30. But even bringing in a validity measure that has 0.9 validity, in other words, it's extremely related to performance, we've only moved from 0.30 to 0.37. In other words, we're still seeing, instead of 60% of the people or 70% of the people we're hiring are failing at the job, now 63% are hiring. Now, it is better, but again, you're having to bring in so many different people, regardless of whether they actually pass the battery or not, to get to that selection ratio of 0.80, that it's really not, it's hard to argue that it's going to add that much utility. Now, let's look at that selection ratio, though, at 0.05. So now if we have 100 people applying, we get to choose the top 5. So again, base rate of 30%. The company has been bringing in people with a 5% selection ratio using whatever method it has, and it's been finding a base rate success of 30% of successful employees. Now, as we increase that validity coefficient, let's take a look at 0.50. So basically a pretty solid measure of performance. It's got a coefficient of 0.50, which means we're explaining about 25% of the success of performance. In that situation, if you're able to reject 95% of the people applying, that 0.50 adding that prediction battery at 0.50 now takes us up from a base rate of 30% success to 72% success. So once you have this kind of data, it's very easy to also then communicate about, so you can ask a company, what does it cost to fire and rehire someone? If they say, well, that costs us $10,000. And then you can go, well, if you hired 100 people and only 30 worked out, and now you're hiring 30 people and 72 of them are working out, that's 42 more people that you don't have to hire next year. And if it costs $10,000 to hire, you just saved $420,000. So just again, kind of looking at this, we can kind of see that again, as you add even a little bit of validity in your prediction, the better your selection ratio, you're almost immediately starting to see in gains. And as we go up to much higher validity, we're also seeing much more utility.